Hello everybody, welcome back to the workshop. So in this video, I'm going to be showing you all how to take and make a butt weld. A butt weld is when you take two different ends of material, usually done in larger stock, and you just butt them up against one another, and then that ends up making a weld right across the seam there. So you could call, I don't know what else to call them, again, you're butting up something and welding it along that seam. Now, there's several different variations of this. This is what I'm working with today. I'm taking a smaller rod, 1/2 inch diameter or 12.5 mil, and I'm welding it to a much larger chunk, into just directly the side of it, just to show you one application of this particular type weld. So I'm bringing this piece up to heat. I'm going to try to take and manage the fire the best that I can here, and still instruct as we go along. And since I got you here, I just want to say thank you for watching this video. Thank you for sharing this with your friends if you've been supporting the channel that way. And thank you for being a sponsor of the channel by supporting us here at Christ Center Ironworks, whether that be through buying power hammer plans and other type things like that, ebooks and whatnot, to help these videos keep coming out on a regular basis. We greatly appreciate all of our sponsors out there that do that and allow us to continue to keep this education free here on YouTube, which I love to do. I love to teach, and I love everyone who subscribes on this channel. Also, for you all out there that haven't purchased anything and you are still supporting us, you're still supporting us just by commenting down below and engaging with the videos. That's super helpful to the channel as well, especially when you hit the like button and you share it around. We greatly appreciate you in any of those cases. So without me sodding on too much more, this is almost up to heat. Again, you want to take your time, bring this up to heat, and then we are going to weld them together. The only process that I've done is I've upset the smaller bar ever so slightly and put a slight chamfer on it to prepare it for this welding stage. Other than that, everything is basically the same. So my right hand is going to drop the tongs on the larger piece, and my left hand is going to take and make the weld on the smaller rod. There we go. That's stuck. Now I'm going to stick this back in the fire, and we're going to make another weld on that. You want to be gentle with it right now because it's not fully welded in yet. It has just gotten more or less a surface weld. So get it back in the fire and take it back up to heat. Now, what we did there is basically two tongs. I picked it up with one pair of tongs, brought the larger, heavier stock that cools quicker, put it against the anvil, then the smaller stock on top, and then tapped it in. But because of the nature of the weld, having a propensity to take and trap scale underneath it, because there's no scarf going on here, we need to take and whack it fairly hard to blow out the scale between the two surfaces. Unlike most welds where you're just doing a lap weld that's scarfed, you want to tap it together. These you need to kind of hit with a little bit of force and magnitude, especially on larger bar stock that has a lot of surface area that scale may get trapped in the core of the bar stock. So just keep that in mind if you're going to do this type of weld. So I'm going to take another whack or two. Now that I blew out that scale, now I'm going to bring it out and I'm going to lightly tap it. It's going to be more rapid blows, lighter succession is what I plan on doing. If you get too careless with this, however, and you try to go too quick at this, what you'll end up happening to you, and this has happened to me before, so I know, if you get too careless with your blows, and you take it too quick, like you're trying to straighten that rod out real fast and stuff like that, what'll actually end up happening is it'll pop loose. You got to make a good couple, 2 or 3 good weld heats to get that weld good and set. I'm not going to take you through all of those heats. I'm going to finish up this little bit of a weld, and you guys can already see how it worked. So that way I can keep a little bit shorter of a video so you all don't have to watch a 5,000 hour long piece of content here from me. But now we're going to move the coke off the side a little bit. This piece should be good and hot. Up and out of the fire. I'm going to straighten it ever so slightly. Again, be careful with this. Right now at this stage, it needs several more welding heats to be in good shape. But it's starting to look pretty good. I'm going to take one more heat on that. You're going to notice that there wasn't really any sparks in my fire. That's because there was no oxygen. I had the piece up hot enough, but I'm keeping all the oxygen burn off of my fire by having enough coke into the fire itself to take and consume the excess free oxygen. I'm also, before I'm bringing out to welding heat, I'm reducing the amount of air blast that I'm using, and this is allowing me to get a reducing fire. So in one of my real popular videos here just recently, it was 3 big myths about forge welding. I'll put a link to that right here that you can go watch. Another very popular YouTuber and very talented blacksmith by the name of John Switzer at Black Bear Forge. If you haven't checked him out, I suggest you go check out his channel. He'll be linked up in the description down below. But he had made a comment, an observation. I had said something about a clinker being in the bottom and how it's a myth that you have to have your clinkers completely out in order to weld. And he mentioned that the reason why I was getting burning, or one of the reasons I was getting some burning in that video, was because of the clinker in the bottom causes me to have to use extra airflow to try to push through that clinker, and it doesn't really add heat value, but it adds more oxygen to the fire. And he is completely correct. The point that I was trying to take and make in the video was that the myth is that clinker in the bottom will somehow inhibit the weld itself, but it doesn't do that specifically. Like, it doesn't coat your metal with something that some sort of substance that will not allow your steel to weld up. It's just a byproduct. The byproduct of having too much clinker in your fire pot is you have to put more air in, and therefore you burn the piece, which is hard scaling the piece, and therefore it won't weld. So yes, very correct. And I just wanted to take and make that little alteration in this video. So there you now know. Again, me and John, we have very similar channels and very similar types of forging. So here I've added a little bit too much oxygen to the fire, so I'm getting a little more burning than what I would like. But that's what happens when you're spending your time yammering and not spending your time hammering. That should be on a shirt. Let's make that the secret passcode this time around. What do we say? Stop your yammering and get to hammering. Alright, got that cleared up. That's good and welded together. I can be happy with that. Again, I would not use this for any real structural purposes. Back in the days when this would have been made from wrought iron, you could do this very structural, and this would be a very structurally sound joint. But because it doesn't have any scarfs, and it's really just more of a surface weld or surface adhesion type weld, I wouldn't take and suggest doing that for anything more than just artistic purposes, or something where you'll later on maybe take and attach something else. Use it as kind of like a rivet pin. So, without further ado, that's it for today. Thank you all so much for watching this video. I hope you enjoyed this. Chuck your comments or questions down in the comment section down below. If I get enough of a reoccurring question or comment, I'll address it in future videos. So that's it for today. Again, God bless you. Thank you so much for watching, and we'll catch you next time.